Hello everybody, welcome to another calculus video. Today we will work on partial derivatives. That's in chapter 14 from Thomas's calculus. So what we'll do here is first we will look at a single variable function and do the derivative of that, and then look at another similar function with two variables and do the partial derivatives of that. So first column, let's do dy over dx, and in the second column let's do partial derivative with respect to x, and third column partial derivative with respect to y. So first function we want to look at is when fx, which is a single variable, is equal to x squared. Simple function. So the derivative, it's not partial, it's derivative of fx with respect to x is equal to 2x. What we do here is we multiply the power of x multiplied by, we put that here and subtract one power, which is the power rule. So x to the power n is n x n minus 1. That's the power rule. That's what we use to get 2x. So let's look at how we would do a function. I would do the derivative of the function if it's a multiple variable function. For example, if it's f x y is equal to x squared y. So if we were to do the partial derivative with respect to x, we assume y is a constant. So we'll say y is a constant a. And when you want to get the partial derivative, we would say partial derivative of x squared. Now since y is a, we will substitute a here with respect to x, because if you are doing the derivation with respect to x, y would be a constant. So we say here, if you differentiate it here, we see we can take a is a constant, we can take that out. Then we have x squared. So we use the same way we did here. We differentiate x squared, which is 2x. And then we can substitute the a, which is y. So it will be 2xy. That's the answer. Now, if we were to take this and do the second derivative, so we say it's the second derivative of x squared a over a partial derivative of x squared. So that would be, we take this value and we do differentiate it again with respect to x. When you take this value and differentiate it with respect to x, you get 2a. And that would be, we know a is y, that would be 2y. So here we want to do the derivative with respect to y. So we write the same function, f x y equals x squared y. And now since we want to differentiate with respect to y, we keep x a constant. So we take the entire function variable x squared and we call that b as a constant. So let's write it as partial derivative with respect to y. And now instead of x squared, we put b y. So if you do the differentiation with respect to y, we would get b, which is x squared. So we'll do the second derivative now. Partial derivative with respect to squared, with respect to y squared of by. So what we really do is take b and differentiate it with respect to y. So since b is a constant, when you differentiate it with respect to y, you get 0. So we have 0 here. So next, let's do another function. So let's say fx this time is equal to x to the power half. And in this column, we'll get dy dx. And here we'll do the partial derivative with respect to x. And we'll do the partial respect to y. So if we, let me erase this to make it a little neater here. So I've written the function again. So we will differentiate this with respect to x. So the f, since it's a single variable function, we can write the differentiation like this. So what we do here is multiply x by the power of x and subtract 1 from the power of x. So when we subtract 1, half minus 1, we get half x to the power minus half, which is equal to half square root of x. So for to define a multivariable function, we'll just multiply it by we'll come up with a new multivariable function. We say it's fxy. We'll take the same function x to the power half and multiply it by y. Simply that. Now if we do partial derivative with respect to x. So if you're doing it with respect to x, we have to keep y constant. So if you want to keep y constant, we will substitute a instead of y. So we can write it as partial derivative with respect to x to the power half, sorry, x to the power minus half, no, it's to the power half y. So, sorry, y will be a here. So we say a. So when you differentiate this with respect to x, what we get is, we know when you differentiate x to the power half, we get half x to the power minus half, and a is just a constant. So we have a here. So the answer would be a to square root of x. You can compare these now. Now the next thing we want to do is we are going to use the same function fxy equals x to the power half y, but we are going to differentiate it with respect to y. This implies we are keeping x constant. So we are going to say x to the power half is going to be b. We're going to assign b to that. So we do partial derivative with respect to y, b, y. That's your function because x to the power half is y. So if you differentiate this with respect to y, we know we get b here because b is a constant. We get b here. So we will take that and then substitute it. So we have b is x to the power half. We could also substitute the value for a here, and we can say a is y, so the answer would be y over 2 square root of x. It's best that you not keep these constants but substitute it back so that you have all the variables, the original variables. Let's do another example. So here we follow the same pattern. We want d over dx for a single variable function, and we do a partial derivative with respect to x, partial derivative with respect to y for a multivariable function. This time Let's take fx equals x to the power, or we'll say 1 over square root of x. And for the second derivative, the partial derivative, let's define a function xy equals y over square root of x. And for this function, we'll use the same function f x y, where y over square root of x. So these are the two functions that looks like this single variable functions, but both these functions are multivariable functions. So let's differentiate this with respect to x. Before we do that, let's write the function fx as x to the power minus half. Now, when we differentiate it, d over dx of fx, a single variable function, what we do here is we use the power rule, multiply the power and subtract 1 from the power. So we multiply the function by the power, which is half x, and it's minus half minus 1. That's 3 over 2. Minus 3 over 2. So we have minus 1 over 2 and x minus 3 over 2. That's half minus 1 is minus 3 over 2. So we have half over x to the power 3 over 2. That's a minus. So if we want to do the derivative with respect to x, what we do is we keep y constant. And we call we say y is equal to a. So we'll write the function again. We want partial derivative with respect to x. So we keep the y a constant. So we say a over square root of x. That's the function. So we can also write this as partial derivative with respect to x. We keep a as it is and x to the power minus half. So when we differentiate it, we can always take the a out because it's a constant and it's a multiplicative function. So when we do partial derivative with respect to x of x minus half. Now this looks like a single variable function we saw here. This is the single variable function. That part is just like the single variable function. So we will differentiate that. So it will be a. We know the differentiation of this is minus half x to the power 3 over 2. And then we'll substitute a. A is y. So it is minus a is y, so it's y over 2x to the power 3 over 2. So that's the answer for this. So let's look at the next question. So here we want partial derivative with respect to y. And this means we keep x constant, as we want the partial derivative with respect to y. We want to see the changes in y, so we keep x a constant. So that means we would assign x, square root of x as a. So let's write the function. Partial derivative with respect to y, we write it as y over a. So we know since a is a constant, we can take this out. So we know the partial derivative of y with respect to y is 1. So it will be 1 over a. And a is equal to square root of x. That would be the answer. So next we will do the differentiation of two functions. For example, so the first column we'll do derivative with respect to x, and in the second column we'll do differentiate the partial differentiation with respect to x. So for this we'll use the function fx equals, let's say, sine x times x squared. And this is going to be a multivariable function, so we'll use it will have x and y in that function. So for this function, let's say we assume the function is sine x xy times x squared. So we see that there are two variables in this function compared to this function has only one variable. Now here we see this is like a gx function of x and multiplied by another function of x called hx. So we know when there's a product of two functions, we know the derivative would be we first write the first function as it is, gx, then multiply it by the derivative of the second function and add it to the derivative of the first function multiplied by the second function. That's the product rule when you have to differentiate two functions, which is a product of when the function fx is a product of product like gx times hx. So let's do this now. Gx would be sine x, and the differentiation of x squared, which is hx, would be 2x plus, then we differentiate sine x. Differentiation of sine x would be cos x, and then we multiply it by x squared, which is hx. So that would be the answer of this differentiation of a single variable function. Now, if we are asked to do the differentiation with respect to x of a multivariable function which has x and y, even if we are doing the differentiation with respect to x, we keep y constant. If we keep y constant, we say y is equal to a. You can use any constant there. We'll say it's y equal to a. So then we will write with respect to x, we'll write the function as sine x a times x squared. So now it's very convenient. It's a you have to differentiate the function with respect to x, but the function has only x, does not have any y. So that's very convenient. So let's look at this function. So this looks like, it also looks like the function over here. There's a gx and an hx. So to differentiate that, we first write the gx as it is, sine xa, and then we differentiate hx. We saw here it was 2x. Then we differentiate sine x now. Now sine x has a constant a. So the differentiation of sine xa would be cos x a times a. That is because we're using chain rule here, and then we multiply it by x squared. And that's the answer, but we need to substitute back the y that was replaced by a. So we say the answer would be sine ya times 2x plus cos xy, sorry, this should be yx, cos plus times y, a is y, x squared. That's the answer. We'll do one more question. The next question also, we'll first do the derivative with respect to x of a single function, variable function, and then we'll add we'll do the derivative with respect to partial derivative with respect to x of a multiple function that has x and y. So here, let's say fx is equal to sine x squared plus 2x plus 4. So this is reduce the chain rule for this function, differentiate this function. And we'll use a similar function for the double variable function, function with two variables. We'll call it sine. We'll put x squared, y squared. We added another y squared here, plus 2xy plus 4. That's the multivariable function we are going to differentiate with respect to x. So if we use this with respect to x, so this is it use the chain rule. So we do differentiation with respect to x, fx. So sine x would be cos, and we keep the second part of it the same, plus 2x plus 4. We are using the chain rule. Now we have to differentiate what's inside the brackets. So we multiply it by what's inside the brackets. How do we differentiate x squared? We know it's 2x plus 2. So that's, we can write it here. I don't think we should put a line here because it will look like it's divided by that. So we'll write it here, that differentiation of the of this function within the function would be 2x plus 2. That would be the answer when you differentiate with respect to x. Now here we are asked to differentiate with respect to, I'll change the color, with respect to with respect to x. So when we differentiate with respect to x, we always keep y terms constant. So there are two y terms, that's one y term and that's another term. So we say y squared is equal to a and y is equal to b. So let's write the function. So partial derivative of with respect to x, and we'll write the function as sine a x squared plus 2xb plus 4. So now this is a function within a function. So when you differentiate it, we use the chain rule. So we say sine is cos, and we write the same function here. Let me underline this. This function is written back. We won't change anything there. So we write that as a x squared plus 2xb plus 4, and then multiply by the differentiation with respect to x of the inside function shown in as a green line. So we'll do that separately. So x squared, ax squared is 2ax plus 2b. That's the final answer, but if this is not correct, we need to substitute a's and e's and get the y's back. So we say that is equal to cos a is y squared x squared plus 2xy plus 4 multiplied by 2y squared x plus 2y. That's the answer. do one more question. This question is taken from Thomas's Calculus, chapter 14. So this is the multivariable function. We are asked to find partial derivative with respect to x and partial derivative with respect to y. So we'll start the partial derivative of f with respect to x. We know when we do partial derivative with respect to x, we keep y constant. So let's write this again, partial derivative with respect to x, and f would be x squared plus 3xa. If we say y is equal to a, plus a minus 1. That's your function. Now that's our function to differentiate it with respect to x. Now since it is a function with respect to x, it's easy to differentiate. So let's differentiate this. And when you differentiate this, when you differentiate x squared, you get 2x. When you differentiate 3ax, you get 3a. And these are constants. When you differentiate constants, it's 0. So if we substitute back, a is y, so we get 2x plus 3y. And they want you to also, they say, at 0.45. So that would be, so if partial derivative with respect to x at the point 4 minus 5 would be 2 times 4 plus 3 times minus 5. So this is 8 minus 15, that is equal to minus 7. That's the answer. So next thing we need to do is a partial derivative of f with respect to y. So when you're differentiating with respect to y, we keep x constant. So here we use a as x squared, and we use x as b because there are two x terms here. So we'll write that partial with respect to y. Now let's substitute the x's. So we have a plus 3by plus y minus 1. Now we have a function with only y in the function, and we are differentiating with respect to y. So that should be easy. So this is a constant, so that's 0 so that is equal to 0, plus when you differentiate this, you get 3b y with respect to y plus 1, and b is x, so it's 3x plus 1. So partial derivative with respect to y at 4 minus 5 is equal to 3 times 4 plus 1, that is 13. So do one more question. So in this question, we are asked to find partial derivative of f with respect to y. So when we want to find partial derivative with respect to y, what we do is we keep x constant. So let's write the function again. So it would be partial derivative with respect to y. It would be y sine x, will say it's a, so it's a y. So this is the function, and we see that it's a product. This function versus this function. So it would be like gx times hx, and the derivative of that we know is gx times the derivative of hx plus derivative of gx times derivative of, not derivative, just hx. So gx is y. We write y as it is. Derivative of sine x is cos ay, and we multiply it by the derivative of the of function ay, which is a, plus derivative of gx is y. Y is 1 times a hx. Really, these are functions of y, so let me put this as y, not x, so it's functions of y. So we have, so gy is gy is y, so g dash y is 1, and hy is sine ay. So next thing we do is substitute x to the equation. So we say y cos xy times x plus sine xy. That's the answer.